So welcome back once again to chemistry online classes, students. See, in the last class, we have completed very importantly hybridization of S, P and D orbital involvement. Okay, and also I given you just postulates of VS-EPR theory, valence shell electron pair repulsion theory, right? And I told you the hybridization SP, SP2, SP3, SP linear, SP2 triangular planar, SP3 tetrahedral, SP3D trigonal bipyramidal, okay, SP3D2 octahedral, SP3D3 that is pentagonal bipyramidal. Same way here also, depending upon number of electron pairs, see I am repeating the word, stressing on the word electron pairs, shape of the molecule is predicted. This was one of the first postulate of VS-EPR theory. The shape of the molecule depends on number of electron pairs. They may be bonding or lone pair. Okay. If number of electron pairs are 2 linear, 3 triangular planar, 4 tetrahedral, 5 trigonal bipyramidal, 6 octahedral, 7 once again pentagonal bipyramidal. Same, right? But this valence shell electron pair repulsion theory does not take into account hybridization, remember. Purely it is based on repulsive forces between lone pair, lone pair, lone pair, bond pair, bond pair, bond pair. That's why I told you repulsive forces follows the order. Lone pair is greater than lone pair, bond pair, and lone pair, bond pair is greater than bond pair and bond pair. Okay? And accordingly, as these electron pairs are, they are all electron pairs, maybe bonding or lone pair or non-bonding, they are all negatively charged. That's why they repel each other. How they repel? They repel in such a way that, or they will try to move as far as possible apart, so that they are arranged in a preferred direction in space, so as to give definite geometry, thereby minimizing repulsion, maximizing stability, giving definite geometry to the molecule. These are 4 important postulates I told you yesterday, and 5th, 6th I told you already. 5th one generally it's an application. That means if any molecule is having more than 2 resonance structure, then only this VS-EPR theory is applicable. Otherwise, less than 2 it is not applicable. Right. Now, yesterday what I told you, all were bonding pair of electrons. So once again I will repeat. Number of electron pairs. Number of electron pairs, and it was a fixed geometry. Fixed geometry. If it is 2 linear, right? 3 triangular planar. Right? Triangular planar. And if it is 4 tetrahedral. If it is S and P, and if the D orbitals are involved, it is a square planar. If it is 5, then it is trigonal bipyramidal. Okay. And if it is 6, octahedral. If it is 7, pentagonal bipyramidal. These are the definite geometries. What I told you in yesterday's postulates. Right? Please try to remember this. An example also given: beryllium fluoride, boron trichloride or boron trifluoride, methane, for this PCl5, for this SF6, for this ISR. Once again I will write examples. You will try to remember. Just one suitable example I am giving you, because there are so many examples are there. Beryllium fluoride, okay. Even CF2 also I can write, or else beryllium fluoride, XCF2, xenon difluoride. Then triangular planar, PF3, all bonding pair, octahedral SF6, SF6. Okay. S sulfur hexafluoride, pentagonal bipyramidal, iodine heptafluoride. Okay. So now this means these are fixed geometries. If they are all bonding pair, definitely linear. All the two bonding pair linear. All the three bonding pairs, I am repeating, all they should be bonding pair involved in bond formation. Triangular planar, tetrahedral, trigonal bipyramidal, octahedral, pentagonal. Okay. Now, sir, if out of these electron pairs, if lone pair enters, then what will happen? That's only I am going to tell you today. If lone pair enters, there is a distortion in the geometry. This deviation in the geometry, distortion in the geometry, even distortion in the bond angle also. Okay. Let us see what. See, for this one linear, I told you bond angle 180. This one 120. This is 109 degree, 109.5 degree or 109.28 degree. Normal tetrahedral angle. Here 3 equatorial, 2 axial. Equatorial 120, axial 90. SL6, all the 6 bonds 90 degree. And lastly, 6 bonds 90, 1 bond 72. Right? Like this I told you yesterday's class. I repeat, the bond angle for this is 180. This is 120. And this is 109.28 or 109.5 degree. Right? PCL5 120 and 90. 120 that is equatorial and 90 that is a axial bonds. And all 6 bonds 90. All 6 bonds. Okay. 2, 3. All 6 bonds 90. And here all the 6 bonds 90 and 1 7th bond, that is 72. Remember. 72, that is the 7th one. Just try to remember this table. This is fixed one. They are all bonding pairs. See, I am telling you about what? If they are all bonding pair of electrons. Now let us remove, if there is a deviation, if lone pair enters, now what will happen? How they will change their geometry and what is the effect on bond angle. Okay. It's very important basic for your next P block elements. Some P block elements, especially you study halogens, interhalogen compounds and compounds of the xenon, where there is one definite question for CET and NEET, definite 100%, 1% for NEET, JEE mains and even JEE advanced also. Okay, let us see. Now this is all about what I have given yesterday, postulates, right? Now coming to main important. See, electron pairs. Okay, there are 3. Sorry, 2. Geometry. Please try to know geometry. What is the fixed geometry? Linear. If both are bonding pair of electrons, linear. There are 2 lone pairs, no, nothing will happen. Okay. So, shape all bonding pair, so no change, linear, okay. And see here how it is arranged like this: A, 2D, AB2. Okay, that's why generally what you write, the type is AB2 type, that is AB2. Example we can give. Beryllium fluoride, just example. Okay, linear. Then, if number of electron pairs are 3, here see here. If number of electron pairs are 3, sorry, one thing I want to show here. Before geometry, bonding pair and lone pair. Here only I will write two bonding pairs. Just will write. Okay, out of three, if there are all B, here will write this. If all both are bonding pairs. Now if it is three, this is over. First part is completely over. If there are three, out of these three, two bonding pair and one lone pair. One lone pair. See, total number of electrons is 2 plus 1, 3 only. So geometry never changes. Geometry, that's what I am telling you. Geometry, triangular planar. Expected geometry what? Triangular planar. Now because total electron pairs shape depends upon total electron pairs. That is why geometry means arrangement of electron pairs in three-dimensional region. Now, if there are two bond pair, one lone pair, see now the shape, there is a disturbance. Okay, now this shape may be. One best example I will show you: two bonding pair of electrons and one lone pair. That is having bent shape. Bent shape. What is that example? Just to see. A atom, okay, B having one lone pair, two bond pairs, one lone pair, right? Band shape, or also called as angular shape, or V shape also. Sometimes in some books they are given bent V shape, bent V shape. Okay, just here. Best examples: O3, ozone, and SO2, sulphur. Here I will show you in detail. For this, we have to remember like this. Ozone, you already know, double bond O, single bond O, two lone pairs, one lone pair, 2, 4, 6, 8. This you already know. And here don't confuse students here. Irrespective of bond order, this is considered as only one bonding pair, and this is one lone pair. Remember. Okay. So no need to write this because you get confused over here. Because our aim, due to this lone pair, okay, which is all done here. See, BP, and this is only LB. So it is what? Bent V shape. Here bond angle 180. Here bond angle is a bent V shaped structure. Generally for ozone, see that bond angle just it reduces to the bond angle for actually it should be 120. Instead of that, ozone will be having the bond angle. Sorry, just I will take it out. It should be 120 only because triangular planar. But here, due to that, so it is bent V shape, it will become due to one lone pair. It is 117.5 degree. Just see, it will decrease from 120 to 117 due to this lone pair. Okay. For sulfur dioxide, so same. Sulfur is having 6 valence electron. Out of that, it will share here 1, here 2. Okay, 1 lone pair over here. Right? Like this. 2, 4, 6. That is 8. Maximum 2, 4. Here also see bonding pair, and this is lone. 2 bond pairs, 1 lone pair, right? So here also bond angle is 112. Like this, it will affect the bond angles, right? Therefore, see, ozone and SO2 are the best example where they are having what? This type of molecule generally it is called just AB2 molecule, and this is called AB2L. That means 2 bonding and 1 lone pairs. These are the best examples. Okay. O3 and S2. That means if the number of electron pairs are great, you will have only one choice: 2 bond pair, 1 lone pair. But oppositely, exactly opposite: 1 bond pair, 2 lone, 1 bond pair, and 2 lone pair is not possible. Such example does not exist. Okay. Right. Now coming to this requirements. Oh, sorry. Students will get confused over here, and that's why I go very slow. Now, third chance for this VSEPR theory. See, after AB2L can also go, that is after 2 and next it is number of electron pairs 4. Number of electron pair. Here see 3 bonding pair of electrons and 1 lone pair. This is the case. Now here this molecule can be just classified as what? AB3L1. AB3L. Okay. So number of electrons pair 4. So what is the geometry? Tetrahedron. Tetrahedron. Okay. But shape, see, due to this 1 lone pair, shape, see, deviated shape is what it is? Trigonal pyramidal shape. For its students, that's why 1 lone pair will destroy. And generally, what we will show here, see how it is. A 1, 2, 3. B bonding pair and lone pair. Lone pair will arrange like this. Lone pair, making a trigonal bipyramidal. Okay, and bond angle here will be, that is actually tetrahedral 109 degree, 109.5 degree. But see, best example to show this type is ammonia, NH3. Best example, ammonia. Ammonia, along with ammonia, there is no another example. See, ammonia generally you are observing. I will show here. See, 1, 2, 3 bonding pair out of 5 and 1 lone pair. Got it? BP, and this is N. Due to this lone pair and bond pair, they move as far as possible apart, making trigonal pyramidal, not tetra, and this is trigonal pyramidal shape, and bond angle is deviated to, this bond angle is 107.5. Actually should be how much? 109.5 real geometry, but it is 107.5. See, 2 degree. This is why? Due to repulsion. It is struck, or it is just a minimum. Instead of coming here, it is due to what? Repulsion. दब गया. Okay? Repulsion की वजह से यहाँ दब गया. Tetrahedron होना था, मगर tetrahedron नहीं हुआ. क्यों? Because of lone pair. 1 lone pair. They will try to move as far as possible apart and minimize repulsion, maximize distance, thereby giving definite geometry. But if they are deviating, then the lone pair has entered. Got it? It is AB3. If there are 4 pairs, another one example coming. If there are 4 pairs, another probability. What is that probability? Let us check here. Same example. All 2 bonding pair of electrons and 2 lone pair of electrons. 2 bond pair, 2 lone pair. Okay, even here also 2 plus 2. Expected geometry is tetrahedral only, no change. Okay, but instead of that it is called band shape or angular. Okay, See here. So best example we can give. Sorry. First, as usual, two lone pairs. Arrange like this. One bond pair. Best, that is B and B. Two lone pairs. Right? LP, BP, BB. Okay? Best example can give for this molecule is what? H2O. For this. H2O. Okay, bonding pair, lone pair. So this bond angle 104.5. Actually, what is the expected bond angle? Expected bond angle same tetrahedral only. Sorry, it should not be the. It should be same tetrahedral only. But we are deviating geometries. Here also, sorry, extremely sorry. Expected geometry is tetrahedral only. Expected geometry is tetrahedral only. But the bond angle deviated to 109.5 degree to 104 degree. Here it is deviated to 107.5. That means ammonia is the best example where it is of the type of AB3L. Means this is central atom. P3 means 3 bonding pair, 1 lone pair. L1, that's for bare lone triangle. This is understood. Okay? If there are 3 bond pair, 1 lone pair, geometry trigonal pyramid. From tetrahedral to trigonal pyramid. If there is 2 bond pair, 2 lone pair, see 2 lone pair increases. Once again, bent shape, bent V shape or angular shape. And bond angle C once again decreases by 2 degrees. Like this, as the number of lone pair of electron decreases the bond angle. Remember, inversely proportional due to what? Repulsion. Right? That's about first 3 possibilities. Now, sir, if there are 5 electron pairs, I told you trigonal bipyramidal. If all are bonding pair, if they are lone pair, let us see how they will distort the shape. From normal exact geometry to shape. Okay? Right. Now let us go for, if there are number of electron pairs are 5. If number of electron pairs are 5. Number of electron pairs are 5. Got it? What is the geometry? And what would be the examples and what is the deviation? Along with the examples, I will show you with the proof diagram. Okay? Let's see. Students, number of electron pairs are 5. That means it is. Right, if the number of electron pairs are 5. What are the number of electron pairs? 5 electron pairs, 4 bonding pair, 1 lone pair. This is one example we will analyze. Okay? And also another example comes, that is if we have 3 bonding pairs and 2 lone pairs. 3 bonding and 2 lone pairs. See how here it begins. Geometry is again the same. Trigonal bipyramidal. Geometry remains same. Trigonal bipyramidal. If they are all bond is there, they will never change. But due to entry of one lone pair, one LP, what is the shape? It will get changes to. This is called generally what we call it as not seesaw. It is actually, if it is 4, then the molecule will have, say seesaw only. Seesaw structure. Okay, not the type. I will show you here example. Geometrical shape, how it is seesaw, how they are arranged. See, actual geometry should be what? Seesaw shape. Seesaw. What is the seesaw shape? Example is SF4. Just what is that? Trigonal bipyramidal. How they are arranged? Like this. A into at the center. Okay. 3 bonds equatorial. 2 above, 2 below. But here, seesaw it gets changes to. This is B, 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 B. Right? This is A, B, fine. This is actually expected one, but the seesaw structure get changes to like this. 1, 2, okay, 3, 4, and 1. Okay, why it is called seesaw? Why it is called seesaw? Just tell you. Bonding pair, bonding pair, bonding pair. Why it is seesaw means just if you take tilt this one, what it will become? See, like this. And 1. Right? These are bonding pair, this is bonding pair. Seesaw, झूले में झूला नहीं. ನೋಡಿ ನಾವು ಆಟ ಆಡೋದು ಅಂತಿರಲ್ಲ, ಈ ಕಡೆ ಒಂದು ಹುಡುಗ, ಈ ಕಡೆ ಒಂದು ಹುಡುಗ ಕೂರ್ಸೋದು. That is called seesaw. Okay? And with deviated geometry, if it is 1 lone pair, 4 lone pair, it is called seesaw. Best example what you can give is SFO, sulfur tetrafluoride. Best example, sulfur tetrafluoride. Sulfur tetrafluoride. See, sulfur will arrange like this. 2 angular and 2 rectangle and 1 lone pair. And this is very VVIMP for medium. We can take like so many directions. Okay? So like this thing. Trigonal, expected geometry is trigonal for both, but if it is 4 bonding pair, 1 lone pair, then it is changes to seesaw due to this lone pair. It will try to move apart and deviate to seesaw structure. Right? So this is 120, but these are 90 and 90. Got it? Okay. Now, if there are 3 bonding pair and 1 lone pair, here also expected geometry remains same. There is no change. No change. B, 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 B. Trigonal bipyramidal only. But 3 bonding pair, 2 lone pair. How they arrange? 3 bonding pair and 2 lone pairs. Here see. 1. I will show you. 1, 2, right? 3. Bonding pairs B, B, and B, and 2 lone pairs like this. Or else 2 lone pairs this side, bonding pair this side. This is exactly what, that is what we call it as T shape. T shape. Okay? T shape. Trigonal pyramidal to T shape when there are 3 bonding pairs, 2 lone pairs. Got it? Okay. Now see here. Best example we can give for this one is Cl3, chlorine trifluoride. Chlorine trifluoride, see 3 fluorine atoms, they are arranged like this. Out of Three bonding pairs will form here and two lone pairs. This is called T shape, band T shape. Just observe like this. If you remove this one, it will be T shape. Like that. Okay. That means see here. In 5 electron pair, there are 2 probabilities. For bonding pair, 1 lone pair, deviated geometry is what? Seesaw. Best example. Sulphur tetrafluoride. And this is also so many times important. VVIP. Very, very important for need purpose. Need purpose. So many times. Okay. And if there are 3 bonding pair, 2 lone pair, trigonal pyramidal, just take just to deviate to what? This is called T shape. Bend T shape, or you can just tell T shape. Okay. Next example, chlorine trifluoride. I'll repeat. There are 3 bonding pairs, 3 set of pairs. Out of that, one lone pair, 2 bonding pair. Band shape. Next example, ozone, sulfur dioxide. Okay. No sir, if there are 4, out of 4, the exact geometry should be what? Tetrahedral. If it is out of that 4, 3 bonding pair, 1 lone pair, trigonal pyramidal, ammonia. 2 bond pair, 2 lone pair. Once again it is a bent V shape or angular shape. Best example, water. Okay, in 4 there are 2 probabilities. 3 only 1 probability. Right? 2 there are no probabilities. Right? That's why I told you 2 or more than 2 resonance structure, then only VSEPR theory is applicable. Try to remember. Okay. And now just I told you there are 5 bonding pairs. See, these are the 2 deviations. 4 bonding pair, 1 lone pair. Okay. If all are 5 bonding pair, trigonal bipolar expected, but it is deviated to seesaw structure. Sulphur tetrafluoride, best example. If there are 3 bonding pair, 2 lone pairs, then it is trigonal to what it is, band T shape or T shape structure. Okay, best example, chlorine trifluoride. This is interhalogen compound. That will come to know next year in the P block elements, in the 17 group elements. Okay. Now after this, 6. If there are 6 electron pairs, what are the probabilities? Fine. Last one. If there are 6 electron pairs, what could be the geometry? There are 6 electron pairs. What would be the geometry? Just to see. Along with example, just I will make it very clear. Now, that means see, what I told you is by 4 bonding pair, 1 lone pair, right? And this time they are called as what? A, B, 4, A, right? In 5 only observe 3 bonding pair, 2 lone pairs, right? And here what you observe AB 3 and that's it. B stand for bonding and stand for. Or here SFO, seesaw. And here CLF3, what I given you? T shape or bent T shape. Remember, that's it. Got it? Okay. Now coming to lastly. Lastly, 6. There are number of electron pairs are 6. Here also 5 bonding pair, 1 lone pair. We have 1 chance, and 4 bonding pair and 2 lone pairs. Right? If there are actual geometry, real geometry should be what? Once again, octahedral. Real geometry. Octahedral. But this is deviated shape is square pyramidal. And here it is square planar. What is the difference between square pyramidal and square planar? Let us see along with the example. See, this type is called as what? AB5L1, and this is called AB4L2. Okay. Right. Now just an example. I will give you for this. We have best example to square pyramidal structure. We can go for boron BRF5. BRF5. Just to see. One bromine atom, right? 1, 2, 3, 4. Fluorine, 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 fluorine. Got it? Another one, fluorine. And just below 1. Because in bromine, how many valence electrons are there? 7. Out of 7, see, 1, 2, 3, 4, 5. 5 bonding pair and 1 bonding pair. Got it? 5 plus 2, 7. These are all BP, BP, bonding pair, bonding pair, bonding pair, bonding pair, and this is 1. So total 5 BP, 1 LP. Total 6. It should be octagonal, but what it is? Square pyramidal structure. This is called square pyramidal structure. Okay. Now coming to the next one, 4 bonding pair and this square planar. For this you can give XeF4. XeF4. See, xenon tetrafluoride. Xenon is a noble gas having 8 electrons per outermost shell. Out of 8, it will share with the 4 fluorine atom, forming bonding pair. 4 bonding pair. 4 bonding pair, BP, 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 and BP. Got it? Still 4 are remaining. That's it, your elements. From below 1 LP. This is called square planar structure. Okay? And these are also very important, very, very IMP for meat. Meat and once again you study repeatedly in P-block elements next year in second year. That's why I am telling you this is a very, very basic valence shell electron pair equation. See AB5L1, AB4L2. These you have to practice and you have to remember. There is no other way. Okay? That's why I am telling you with examples. Example के साथ इसलिए मैं आपको क्या कर रहा हूँ समझा रहा हूँ. नोट ಅದಕ್ಕೆ ನಾನು example के साथ ನನಗೆ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. Right? ನೋಡಿ ಎರಡರಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದೆ. 2 lone pairs, no probability. 3 ದಲ್ಲಿ 2 bond pair, 1 lone pair. ಓಕೆ ಇದ್ದಾಗ ಬೆಂಡ್. Ozone SO2. 4 ಇದ್ದಾಗ 3 bond pair, 1 lone pair, ammonia. 2 bond pair, 2 lone pair, water. Okay, bent shape. But sp3 hybridization, right? First one sp, next sp2, next third sp3, fourth one sp3d. That's only 5. 5 orbitals, sp3d. Got it? Simple. Tribunal pyramidal. But deviated what? There also chance 4 1. If there are 4 bonding pair, 1 lone pair, this is called seesaw. 3 bonding pair, 2 lone pair, bend shape. SF4, CLF3, example we have done. And lastly 6. 4 bonding pair, 2 lone pair, square planar. But 5 bonding pair, 1 lone pair, square pyramidal. Boron pentafluoride, bromine pentafluoride, and here it is xenon tetrafluoride, XeF4. Okay? Right. Now last another one example which was very, very important and it was asked in the IIT one time. What is that last one? If there are 7 pairs, these 7 pairs there is no any deviation. Got it? So that's what. But if all bonding pair are bonding pair, I will be the tetrafluoride. See here. 1, 2, 3, 4. First 4. They are in 90, 90, 90. 5, 6. And this is like this. Here. This is called pentagonal bipyramidal. Okay, pentagonal bipyramidal. Suppose if you go for XeF6 now, xenon hexafluoride. That is xenon hexafluoride. Other examples. Xenon hexafluoride. See, these are all bonding pairs. BP, DP, 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 all bonding pairs. 7 bonding pairs. Iodine heptafluoride. All 7 bonding pairs. Therefore, geometry is what? Pentagonal. Pentagonal bipyramidal. Pentagonal bipyramidal. Now another example just tell you. HCl, xenon hexafluoride. See, xenon out of 8, 1, 2, 3, 4. Okay, fluorine square planar. But there are 6, 1, 2, 6 over and down. What about another one? Still 2 electrons. That's only. Okay, so here 6 bond pair and 1 bond. Total how many? 7. Actually it should be of pentagonal bipyramid, but distorted geometry. Distorted, deviated geometry. Deviated geometry is what? Distorted octahedral. Distorted octahedral. So that's about this particular what we call it as VSEPR theory. See, this is also very important. VVI for need. And this was asked in one time IIT. Okay, that is now it has been changed as what? Advanced. Okay, JEE mains afterwards JEE advanced it has been asked. Pentagonal bipyramidal, but this is a distorted octahedral. Remember, deviated geometry, distorted octahedral. So this is in detail. When lone pair comes into entry into the formation of a molecule through this repulsive force, it will have what? Deviation in the geometry even in the bond angle. Okay. But this theory was not applicable for all the molecules. It has its own limitation. For ions and for that's only for ions it is not applicable. To explain formation of ions, there is a need of another theory. Lastly, what it is? Molecular orbital theory. That's only in terms of wave mechanical model. Lastly, we will study MOT. What is that MOT? Molecular orbital theory. Right? So that's about the VSEPR theory. Now finally just to conclude, students, because you may get confusion. Once again I will make you that confusion very clear just by having this. Please take that. If the number of electron pairs are 2, okay, all bonding pairs, right, linear geometry, beryllium fluoride, best examples, right? The number of electron pairs are 3. Out of that, 2 bond pair, 1 lone pair. Deviated geometry is bent. Okay. Example O3 acid. And number of 4. Out of 4, 3 bond pair, 1 lone pair. Got it? It is what? Trigonal pyramidal. Okay, best example. No sir, 4 only. 2 bond pair, 2 lone pairs. Right? It is a bent V shape or angular. Okay, best example for right? If the number of electrons are 5, now get 4 bonding pair, 1 lone. Then it is C star. Expected example is SL4. Okay? Right. Then the 5 only 3 bonding pair, 2 lone pair. It is a T shape or bent T shape also. Best example CLF, chlorine trifluoride. 6 4 bonding pair, 2 lone pairs. Okay, square planar. Square planar. Best example, xenon tetrafluoride. 6 only, 5 bonding there, 1 lone. Okay, now then it is a square pyramid. Square pyramid, that is BRFR. Or also you can tell XCOF, xenon oxy tetrafluoride. Best example. No sir, it is all 7 bonding pairs. Okay, pentagonal bilateral. Pentagonal bipiramidal. It is iodine heptafluoride. Best example. No sir, in 7 there are 6 bonding pair, 1 lone pair. Then it is distorted octahedral. That you can do. Let's see. Yes, xenon tetrafluoride. So like this, students, I think now you are able to, right? That is, remember very easily this distorted geometry. Okay. I'm repeating, students, once again. Just listen here very carefully. If all are bonding pair, then linear geometry remains same, shape remains same. If all are bonding pair, if 3 electron pairs are there, all are bonding pair, then the geometry should be what? Triangular planar. But out of 3, if there are 3 bonding pair, 1 lone pair. Due to this lone pair, there is deviation from triangular planar to bent shape. Ozone, see or seen like this. Right? And SO2 also like this. Got it? Okay. Then if there are out of 3 electron pairs, only 1, there is no any chance of 1 lone pair, no one pair. Over, only 1 probability. In 4, there are 2 probabilities. 3 bonding pair, 1 lone pair, but total 4 expected geometry is tetrahedral, but it is deviated to trigonal pyramidal. Then, and it is 3 bonding pair, 1 lone pair. Best example, ammonia. See, just as shown in this. Ammonia. Got it? This is trigonal pyramid. If there are 2 bonding pair, 2 lone pair, then it is bent shape water. Yes, see here hybridization sp. Here also hybridization sp only. Sorry, sp2. Here hybridization sp2, and here hybridization sp3. Here hybridization sp3. Shape should be tetrahedral, but it is no. Bent here it is pyramidal, and here it is also bent V-shape. See, just as shown in this. 2 lone pairs. Got it? Or else like this. Got it? Simple. Now see, there are 5 sp3d hybridization. It should be trigonal pyramidal, but it is deviated to what? Seesaw. Due to 4 bond pair, 1 lone pair, it is seesaw. What is the seesaw, sir? Just as shown you here. Yes, therefore 2 perpendicular, 2 angular, 1 lone. This is SM4. This is called seesaw. But hybridization is sp3. Why? Because 5 outflows, definitely. And this is also sp3d only. Expected geometry was trigonal bipyramidal, but there are 3 bonding pair, 2 lone pair. Once again, more what? Repulsion. Therefore, it gives rise to Cl3. What is that? Band shape. Also, and 2 lone pairs. Remove his minimum. Simple. Right? And lastly, just I will not make confusion. 5 is over. Now 6. Octahedral. What is the geometry? sp3d. है ना due to two load pair. What is that? Xenon 1, 2, 3, 4. This is square 4 bonding pair, 2 lone pairs. Easy. Got it? No sir, there are 5 bond pair, 2 lone pair. 5 plus 1 6 octahedral. Geometry expected. sp3 due to hybridization only. But it has changes to square pyramidal. Okay. Therefore, best example BRF5 bromine pentafluoride charge square pyramidal chloride हो गया, क्योंकि ब्रोमीन के 7 इलेक्ट्रॉन्स आते हैं, 7 में से 5 क्लोरीन एटम के साथ शेयर हो गए, अभी बचे 2 ब्रोमीन। नहीं सर आप एक xenon टेट्राफ्लोराइड दिए, ये कैसा करना सर? xenon में 8 है, 4 फ्लोरीन एटम हो गया, 4 इलेक्ट्रॉन्स के साथ भाग गया, राइट? अभी बचे कितना? 4 में से 2 ऑक्सीजन के साथ भाग गया और ये लोड पे रहेगा, राइट? गॉट इट? सिंपल। So this is called, this type of arrangement is called square pyramidal. आप ये याद रखना, प्रैक्टिस करना, otherwise you won't understand anything. हो गया। देखो ये 2 चांसेस कहाँ? अगर चेयर हम 4 बॉन्डिंग पेयर 2 लोन पेयर रहा तो स्क्वायर प्लेनर, नहीं सर 5 बॉन्डिंग है 1 लोन पेयर रहा तो स्क्वायर पिरामिडल। अगर हाइब्रिडाइजेशन क्या है? sp3d2 एंड ऑल 6 बॉन्डिंग पेयर रहा तो ऑक्टाहेड्रल। नो चेंज, डेफिनेटली नो चेंज इन ज्योमेट्री। दैट्स व्हाई say geometry remains same but only shape changes. That's the difference. So then what is the difference between geometry and shape? Geometry is arrangement of electron pairs in 3-dimensional region, but shape is a deviated from real geometry. Got it? That's the importance of PSCPR. Lastly, very rare, all 7 bonding pair existed example only one, that is iodine heptafluoride. Very important. No sir, out of that is 6 bond pair, 1 bond pair, only one probability, that is I will observe in xenon hexafluoride. Once again repeat here. 1, 2 first pair लेना, 4 corners, एक ऊपर एक नीचे, ये हो गया ना सर? अभी 2 इसके पास 6 इलेक्ट्रॉन, अभी 2 इधर नहीं तो इधर, कहाँ भी चलेगा, इधर भी चलेगा, इधर भी चलेगा, इधर भी चलेगा। टोटल सम। This is called distorted outline। ये एग्जाम्पल यार। So this completes BSEPR. So students, I will stop here today because otherwise you will get confusion. So tomorrow's class. See, tomorrow's class I will teach you how to write resonance structures, resonance energy. What is resonance hybrid? What are canonical structure? Another very important tricky type of concept I will make it very clear, which will help you to write resonance structure in organic chemistry. Because there are, see, students, I am requesting you, please try to practice in the home chemical bonding as when the class is over. Especially all concepts are very important in chemical bonding. It's a strong basic for your second year. Okay, so that's why I said first started what Lewis dot structure. From there we have jumped, we have understood after Lewis dot structure very importantly valence bond theory. After valence bond theory, hybridization. After hybridization, now I have given you the idea of what BSEPR theory. देखो ये तीनों होने के बाद BSEPR theory आपको मालूम रहेगा, राइट? इसके बाद मैं आपको रेजोनेंस स्ट्रक्चर कैसा लिखना वो आपको मैं सिखाऊंगा, क्योंकि रेजोनेंस अगर मैं बीच में पढ़ाया तो आपको कुछ भी समझ में नहीं आता था, राइट? व्हाट आर सिग्मा इलेक्ट्रॉन्स, व्हाट आर माय इलेक्ट्रॉन्स पूछते थे, इसलिए वैलेंस बॉन्ड थ्योरी and hybridization very important to understand this BSEPR. And next, resonance concept and resonance structures, resonance hybrids and resonance energy. Okay, that I will tell you tomorrow along with the, if time remains, we will go for lastly molecular orbital theory. Okay, so today enjoy the day and practice make man. Have a nice day, enjoy the day. Thank you, bye bye from PANCHNATH.